Ladies and gentlemen, welcome back from the break. It's 1600 sharp. Thanks for being so precise. We really appreciate that here in Finland. Our next panel is about extremely interesting topic, digitalization in aviation. And our next moderator is Principal Advisor to the EASA Executive Director in charge of innovation, with a very impressive record in the field of aviation engineering. Jean-Marc Cluzeau, welcome to the stage.
Ladies and gentlemen, good afternoon. It's an honor for me to be invited to chair this panel on digitalization on aviation. Digitalization is a very vast topic. I think that we have all heard on big data, blockchain, digital twins, artificial intelligence. Those new technologies are going progressively to be applied in virtually all domains of aviations. I have started to make a list of a number of applications which are either under development or research or are already being applied, and it's quite impressive. In the field of design of aircraft, we are moving towards autonomous flight, so that's the holy grail, but before we reach the maturity on technology for autonomous flight, we can see applications of artificial intelligence in sensor calibration, icing detection, flight control law optimizations, and many other applications. On aircraft operations, one of the key applications is the augmented crew intelligence, as far as you can even augment on the intelligence of the crew. But we can see applications, for instance, under development in the flight preparation, the use of artificial intelligence for NOTAM analysis, artificial intelligence still for the optimization of the flight profile. On aircraft maintenance, we can see the use of big data and artificial intelligence for predictive maintenance. Also in the field of engine, the use of digital twins, also for the use in predictive maintenance. The use of blockchain for the component logistic chain. Also for the airworthiness management of component. On air traffic management, we can see also that artificial intelligence will be used in strategic planning, trajectory prediction, refining time and wake separation, ATC optimizations, and further automation, and so on and so forth. There will be also plenty of applications in urban air mobility. So that's just the start of the list, but there are plenty of other applications, which shows that, in fact, we are really at the start of a digital revolution in aviation. And of course, in this panel, we won't be able to look at all the different elements of this forthcoming revolution. We'll touch upon only a few applications of digitalization in air transport. But what we'll try to do is to illustrate through a few examples what are the main challenges and benefit from efficiency and safety point of view of digitalization in air transport. And for this, I'm happy to welcome the panelists on stage. First, Erick Ferrandez. Erick. So Erick is the head of Safety Intelligence and Performance Department at EASA, and he is also the Data for Safety Program Manager, and he will tell us what will be the impact of data for safety on the aviation system. The next panelist is Frédéric Sutter. Frédéric Sutter is the digital transformation leader at Airbus, and he will explain us why artificial intelligence and advanced analytics are a must to address the increased complexity of the aviation system. Jourdan. Jean Jourdan is the Chief Technical Officer of the Thales Airspace Mobility Solutions business line. Jean will focus on air traffic management, and he will explain us why the ATM domain requires new safety paradigm now. Next is Pierre Jouniaux. Pierre Jouniaux is the CEO of Safety Line. He will present us 2 applications of big data to improve safety and efficiency of aviation operations. And then Luuk van Dijk. Luuk van Dijk is the CEO and founder of Daedalean. With Luuk, we will look further into the future of air transportation, and we will explore the next century of flying. So I think that we have quite an exciting program in this panel. But first, I would like to start with some safety instructions for the panelists. This is not water. This is Finnish vodka.
Okay.
And it's really excellent, but it's a bit strong. So what I advise is to drink good, to drink with moderation, and if you drink just the right amount, you will see it will make the panel relax and lovely. I think that's the main use of the moderator in the end. It's to moderate the alcohol consumption of the panelists.
Well done.
Erick, you start with your presentation.
All right, so I will present to you the Data for Safety program. I have presented this program many times. The first time I will present that with just 1 slide and in 5 minutes. So thank you very much, Jean-Marc, for that. So let's try to do that. So first, and you will have to follow me, we will start with the right part of the slide. First is why are we doing that in EASA? Why do we have such a program? So I would like to capture that in 1 sentence. So it's because we want to identify and mitigate the safety risks in Europe. So that's why we do it. We want a program that will deliver safety intelligence. So to tell us where are the risks, so to know where to look. And this morning somebody mentioned a predictive risk management, so to see it coming and be able to act on it. So that's why we have the Data for Safety program. Now what we want with that is of course to enhance the safety of the system and consequently the efficiency. Because if you know where to look, if you see it coming, if you act in a proportionate manner, then you can have better regulations, you can have appropriate resources and put your resources where it matters for safety. So that's the why. Now, what are we doing? Now, go to the left side. We want to use the data that are out there and the expert knowledge. So you may think, but we already do that. And all of you, in your different sectors, you, I'm sure, capture some form of data and you analyze them. We have seen it again with the winter operations, for instance. But the problem we have today is that each of us, authorities, operators, maintenance organizations, we capture a fragment of the data and we analyze with a fragment of the knowledge. So we do things with that, because that's the SMS, we do a number of things. But if each of us, we have a fragment of the data and of the expert knowledge, we have a fragment of the safety picture. So what we want to do with the program is to put all these fragments together to have the global picture of the European safety system. So that's what we do with Data for Safety. So how do we do that? Then we want to use all these data technologies. So big data, certainly, but any other technologies that can help, data mining, artificial intelligence, we want to use that. So that's why safety intelligence, safety and efficiency, putting the data jigsaw and the expert knowledge together and taking advantage of these technologies. We put that in the system and we deliver safety and efficiency. So what type of results, tangible results, do we expect? many of them. I will give you only 2 examples that I will take at the European system level. You are familiar certainly with the annual safety review and the EPAS. So the annual safety review is a document published by EASA every year, and it's there to tell us about the performance of the system. The EPAS is where we put the safety actions, the mitigations, what we are doing to improve the system. So when we build these 2 documents today, we do it, EASA, mostly with the occurrence reporting, with the European Central Repository. So imagine if tomorrow we can have data for safety fully operational, and we do these documents with the flight data, radar data, maintenance data, training organization. We put everything. Clearly, the measurement of the performance in the annual safety review and the mitigations will be much more precise because much more proportionate to the actual safety issues. So that's, in a nutshell, what we are trying to do. An important point, and it was mentioned by the CEO of Finnair this morning, we do this program collectively. Data for Safety is a voluntary partnership. And today, we are in a proof of concept phase. So we have a limited number of partners because it's extremely complex in terms of the technologies, but also in terms of the governance we need to establish. So we have a limited number of partners. Here they are. As a matter of fact, normally this week we'll have 2 additional airlines that should join us. And with them, we are building this program. So I would like to conclude just by saying that I heard something very interesting by the CEO of Finnair. He said that the safety data are our common good. I think for data for safety, it's very true, because for us, this program cannot deliver if we cannot convince our safety partners to share their data and their expertise with us. Thank you very much.
Thank you, Erick. And good afternoon, everyone. So I believe that we are really at a turning point when it's related at Airbus, at least, but I'm sure it's shared with all stakeholders in the aviation about how to handle safety in our own operations. It's a turning point because we come from a time with few commercial aircraft generating few data into a world where we have many, many aircraft, and the projections is, our forecast is for 45,000 commercial aircraft by 2037, doubling or more than doubling from 2018 numbers. And those aircraft generate more and more data. And so we need artificial intelligence to be able to just cope with the increasing complexity and the increasing volumes of those data generated by the industry. And within those data, what is really interesting is that when we compare the trend or the growth of the Airbus fleet flight hours, it will be tripling over the next 5 years, or it has been, our forecast is to triple between 2009 and 2023. So basically, we could imagine that the reported occurrence would follow the same pace. And in fact, it's not. The reported occurrences are expected to grow twice the pace of the Airbus fleet flight hours. And this makes us a mandatory challenge that only digital can help us to handle and to address, which is how to just, over this volume of data, just compute and identify weak signals as we have to do it in our own product safety processes. And this is a real challenges, and we start with various initiatives towards natural language processing and the model in order to try to identify contextual information from the different text reports we receive. But it's also trying to launch research programs with academics, like the one we have with ENAC, for fostering these natural language processing, text mining model that is supported by artificial intelligence. And this is a huge challenge, but it is really critical for us at Airbus to address it today and to prepare the future growth in these volumes of any kind generated by the aviation industry. But big data and digital transformation supports already the airlines. Our customers are already largely investing into big data technologies. And they do it also in order to support their safety teams. Those safety teams usually are in charge of producing a lot of routine reports, and it's very time-consuming for them to do it. So we observe with Skywise users within airlines community that they radically can reduce and automate the effort in order to produce these routine reports by a matter of from up to 3 weeks into less than a day. And then they can focus on the investigation, the root cause analysis. And they can do it because at an airline, within their private environment, private domain within Skywise, they have access to 100% of the occurrences, 100% to the logbook. And so they can perform within their environment all the data fusion needed in order to have a better root cause analysis as they need. And usually, the safety team also spent a huge amount of time to support engineering departments, maintenance department. And having this kind of a data lake enables them to become more efficient in how they collaborate with their peers and their colleagues within the airlines. But it's also about preventative safety or risk management. And we have examples where a large airline operating 7 different AOCs across the world managed to identify 40 different safety events that trigger additional reports, and where they can ask pilots to generate those reports internally in order to be more efficient in preventing the risk associated to safety. So big data is already a reality within many of the airlines, and we are just starting to see the potential of big data and digital technologies in data fusion and collaboration within an airline across those data. And all of that without impacting the confidentiality of their crew. And this is something which is extremely important in most of them. And the technology is today ready in order to handle safety data with a level of data policies and data governance associated to it in an efficient way. So, collaborating across around safety and across digital technologies is a matter of culture, and also it's a matter of trust between parties. We observed that we have various data lake or digital platforms that are available today on the market, Skywise being one of them, but we have also a lot of different initiatives from various players. So the technology is there in order to foster the collaboration among different parties. The technology is there just to remove the complexity and the burden for an airline to share data with the different stakeholders. However, it's about having access to those different data. And today, we could do much more collectively. Much more because, for instance, as an OEM at Airbus, we only get access to the data that the industry or that the airlines are okay to share with us, or the ones that are contractually mandatory for them to share. So, in order to improve the product safety, which is our ambition, we need to have more systematic and more exhaustive data sharing processes. The technology is there for sharing data. However, when it's matter to data fusion, then the technology is not ready yet. And data fusion can occur between a text report and to correlate it with flight data, flight ops data, and a lot of other different data, weather data, ATM data, and all those data today remains largely siloed in our different organizations. And we know by experience that improving and enhancing the safety at the aviation industry is a matter of just fusioning those data and sharing the domain knowledge around those data in order to improve and to identify weak signals before they occur. So we are at the starting point. We are also at the turning point in the industry. And what is critical as we see it is really to enforce data governance that will move from a contractual obligation to share data into a real collaborative mindset across different parties where we agree to share, assuming different conditions like the identification of some of the critical and sensitive data, but where collaboration across safety data is the key essence of the industry and of the path moving forward. Thank you very much.
Thank you, Frédéric. Good afternoon. So, digitalization is a revolution. So this has been said as an introduction. So it brings a lot of new technology. And the question that we have in a company like Thales is how can we master in a domain like aviation this new technology? Okay, so what I've tried to do in this introduction and in this panel is to try to highlight the challenges, the perspective, and the risk that we have from an engineering point of view with the arrival of this new technology. So what you have here is just a summary on the ATM domain, so where we are and where do we stand on the ATM domain. Okay, so I will not address at all what's happened on avionics or on EUTM, so I've very focused on the ATM in this couple of slides. Okay. So we have on top the evolution of from an operational point of view. Okay, so it's clear that we have to decrease the environment footprint. We are in front of the traffic growth. The airspace become more and more rare resources. So we have a new vehicle that we have to manage. So in the middle, you have the trend of the evolution of the ATM itself. So more and more we introduce automation. So we have to manage interoperability, openness, security, and remote control, like remote tower. Okay, so we have some competitiveness issue already with the harmonization of the ANSP safety, which are not the same from the same ANSP. So we have to manage the COTS. Okay, so this is a major difference that we have with avionics. Okay, so ATM system is a million line of code, so there are a lot of COTS that we have to manage. And the incremental qualification. So we have two pressure coming on ATM. Okay, so the first comes from the authority, so the regulation, EASA, and the other authority, because of the introduction of the automation and so on. So the level of safety is increasing. And on the other side, so we have the digital revolution with this new technology, like AI, big data, machine learning, data mining, and so on. And so we try to introduce in this system this new technology. So the current situation of the ATM, so is we rely for the COTS on mainly on the service experience, with a lot of issue of life cycle mismatch. So which would not be any more sustainable in the future, with the increase of the level of safety and the introduction of new technology. Yes. So if we go on the right hand side of the slide, just from the authority, so they will require to be more glass box, and to apply to fully apply the compliance to the DO. Okay, so we will run into a very big competitiveness issue. On the other side, okay, so of course there are some work which has started, like the explainable AI, in order to allow us to provide evidence for the safety, in order to build the safety case. But it's still a big breakthrough that we have to go through, and with a lot of challenge, technical and scientific challenge, which are in front of us. Okay, so just in this picture, we can see that ATM will be maybe in trouble in just the coming years because the competitiveness and the technical challenge, so they will be very complicated to fulfill. What I've tried to do is to try to sketch out a kind of roadmap. Okay, so of course, don't believe this is a unique roadmap that you can draw. Okay, so on different perspectives. So first, on the operational benefits that we can get with this revolution on ATM, the consequence that we will have regarding the aviation platforms, and then so what's going on the safety barrier or safety constraints. So it's very small because I have to reduce from 5 slides to 2 slides.
Cheating.
So I hope you can read in the back. Anyway, so I hope you will get the slide anyway. Okay. On the top, you have the operational benefits. So we can have a 10th of dot here. So I just put a few. But okay, so we are already working on that in Thales, and we have many applications that we can build from this new technology. Okay, so resilience monitoring. Okay, so this is very important when you detect from the data mining the weak signals. Okay, so and so we can detect in advance and to be very proactive in detection of default. Conflict resolution, sorry. So to quick identify possible solution. Okay, so to solve a conflict. So airspace complexity for the workload management and so on. Traffic forecast, so to find an optimization of the ETA, ATO, and so on. To support the ATCO, so to measure the pressure, the efficiency of a controller. And at the end, this will provide you a robustness environment where we can run thousands of millions of tests in order to increase the robustness of our systems. So, and there will be plenty of other applications like that. Okay, so if we look at the platform, there is also a revolution which will occur. Okay, so of course we will have, on top what we have is what I call the operational platform of ATM, and bottom is more the aviation data platform. Okay, and I've tried to interleave or to get a better understanding of how does this platform will evolve. Okay, so first we have the current operational platform, okay, which is closed, which is a real-time platform, a safe platform, and so on. So below we will have pretty soon the data for safety platform. So aviation is aviation data. So there are a lot of company or initiative on that point with some ATM digital services. So on top, the next step will be to have an open ATM operational platform. So open in the sense that you will be able to introduce within this platform some data coming from the open world. Okay. So this will be, to do that, we need to have the safety critical interoperability means, safety critical plugin. Okay. So on the bottom, so the data for safety platform will take all this volume when we will move to what we call the ATM digital twin platform. So a digital twin platform, so Jean-Marc has mentioned this, is a digital virtual ATM system, so which allow you to run a million of what if through simulation. So we use that for training. Okay. So then the next step after that will be to start to think about a connection between the two platforms. So either we will go to one unique platform, or with two platforms which will interoperate together. Okay. So we have to introduce other constraints on the digital twin platforms. We have to become real time. So we have to manage the safety, the security. And at the end, where we have this real-time digital enhanced ATM operational platform, which will be able to take advantage of what we will discover in real time on the digital platform.
Jean, you managed to squeeze 6 slides in 3, but then you should also squeeze 20 minutes of presentation into 6. That's the second challenge.
I'm done. Sorry. So the last part is about what's going on the safety constraints. So I'm almost done on safety constraints. Okay, so just I try to sketch out here the roadmap on that. Okay, so and the tendency. Okay, so today everybody knows here the classical safety approach, which is based on the engineering judgment, and the approach is a failure approach focused on the analysis of hazards. One step is to introduce another way to be more efficient by introducing methods based on the non-interference analysis methods, which consist to focus the same approach, but only on the critical chain. Then we can, from the digital platform, we can identify some new hazard from the weak signals, and in this case, reintroduce in the safety methods these new hazards, and to not just rely on the engineering judgment. Okay, so to get advantage of what we discover from the digital platform. So then to improve the safety method by using the failure, but also using the success cases. At the end, we can use a dual safety platform, the one which uses the classical approach of safety, plus some advice that we can provide to the end user. Okay, and at the end is the unified safety approach, which will consist to what we get from the digital platform to be automatically introduced in the safety approach. Okay, so I'm finished, I'm done. Okay, so these roadmaps are not perfect, but just put the light of the 3 different perspectives: operational, platform, and safety. Thanks a lot.
Thank you, Jean. I think before your presentation, I thought that ATM was complex, but now I know it's really complex.
It's very complex.
Very complex, yes. Thank you. Pierre, it's your turn. Maybe, Pierre, before you start your presentation, you say a few words on your company, because sure. I think that Thales and Airbus are well known, yeah. But your company may not be known to the audience.
I will take this one. So, good afternoon, ladies and gentlemen. So it's really a pleasure and an honor to be here and to address this crowd about this new topic and about digital worlds, about big data and airline operation. So I picked up these words. So big data is a buzzword. For me, it's a big word. Let's try to see if we can make it simple and make it understandable and what we can really do with those data. So first, yeah, a few words about who we are. So maybe a few years ago, it would not have been possible for us to be in this audience, because with digital industry, it's an opportunity for new commerce to come and provide some solutions to the aviation, where for many years things have changed very little. I used to be an airline pilot, so we operate aircraft right now like we were operating them 30, 40 years ago. So it's quite important to see what digital can bring and what it can transform this industry. So SafetyLine is a kind of startup. Those I started 8 years ago now, and we combine actually data science, digital also expertise and aviation expertise to create some new product, new solutions for the airline and airport operators. So in the first, at the beginning, there is the data. The data is at the heart of safety, as also the black box you see here was the main, in fact, thing that was used to explain the accidents. But those data are full of there is a wealth of information in those data. There's also a wealth of information in the ATM, from the ATM world, in the radar data. The thing is, what we can do to use those data and combine it with real-time data, like weather data, for example, to, of course, improve safety, because safety is paramount, it has been said before, but also the efficiency is kind of the two sides of the same coins, I would say, because with the data you can identify hazards, you can identify threats, but you can also identify that you have some lower than possible, lower efficiency that you can achieve. So I will explain it through two examples. It will make it, of course, clearer for the audience. So the first one, yeah, I need to click on the right place, is OptiFlight. What we call OptiFlight is a new product we introduced 2 years ago now. And it's based on, in fact, machine learning. Why machine learning? Because we, in fact, use QR data, so flight data, to create individual performance model for each individual aircraft. It means that we don't use models from the manufacturer, but models for each aircraft, and each aircraft, through its life, it has a performance that can change during the time. We also use historical trajectories. I will explain a little bit later why. So we can use QR data. We can use also ADS-B data, for example, to look at all the possible trajectories flown by the aircraft, for example, to provide recommendation of directs to the flight crew. So based on those data and based on real-time information like weather data and flight plan data, we will run millions of computations to see what are the opportunities for one flight. So one of these opportunities is to improve the climb phase. So instead of using the standard climb profile, we provide the flight crew with optimized and customized climb schedule that will help to save up to 6% of fuel during the climb. So that is a lot. For example, for a 737, it means 80 kilograms of fuel. We also used this approach to provide, like I said, some recommendations of directs for the flight crews. So here the roads are joining between safety and efficiency, because on the right side you see a very popular tool used by pilots. It's an application, weather application called EASA, and we were able to bring what we are doing into the EASA tool to provide also the direct recommendations together with the weather, and so that the pilot can see at the same time the weather and how much fuel he can save by going through that direct. So the digital world makes things possible in a very quick way because we developed that with EASA, in fact, GTD, the company that develops EASA, in less than 1 year. So it's very efficient, and now it's used by many airlines. So this is very, very interesting to see what we can do with this digital information. So this one was one example. I will continue with another one that is more on the airport side. And again, it starts with the data. It starts with the radar data. And this time, it's what is quite important is that the fuel that is burnt on the airport, on the air side, is a very large amount, as it accounts for 5% of the total fuel consumed by the airline industry. So 5% of the fuel is burnt on the ground. It's quite inefficient. It's inefficient why? Because we have very old practice, of course. We use radio to contact the control tower, and they give us a routing, but this routing does not take into account the real, in fact, opportunities or the real fuel consumption of each aircraft. So what we do, and we started working with Aéroports de Paris on this project, we can use all the radar data to identify what is the real consumption for each trajectory on the ground. And for example, an aircraft will not burn the same fuel on a straight line or when it's making a turn or stopping and starting again. So we break down the trajectory into all these, in fact, steps. And based on that, we can know how much fuel is burned for one trajectory. And this can be turned into an efficient, and this is a project we have now with Aéroports de Paris, to tell the air traffic controller what is the best route for this aircraft to reduce the fuel burn for his taxiing. And this is really important because with the growing traffic, it becomes more and more a concern to make everything possible to reduce the carbon footprint of aviation. So it's just a few examples, and I'm really pleased to share that with you today. Thank you very much.
Luuk, your turn, and please also if you could say a few words on who is Daedalean and what you
I totally forgot to put a slide in about ourselves. Before I do that, how many of you are pilots or part-time pilots? Oh dear. Okay, how many of you think that job will not be replaced by a machine in your lifetime? Will not be replaced. So any attempt to replace you with a small computer program, futile. No? Oh, okay. Or maybe I gave it away because the slide is already up. My name is Luuk van Dijk. I founded a startup in Zurich called Daedalean, and our aim is to remove the human factor out of the control loops, starting at the lower level ones. So self-flying airplanes and self-flying cars, if you buy into the eVTOL excitement. So somebody said it much better than me, so I didn't find it hard to come up with this slide. We've all heard a number of times today how incredibly safe flying is. And it truly is, given the inherent danger of being at a high altitude at a high speed. So, the physics is dangerous, but due to a century of engineering, of course, also thanks to the wonderful rules that have been put in place by the regulators, but it's now, pretty safe. And that's actually a marvel of engineering. And, a pretty good reason to be pleased with that. But as has also been pointed out a number of times today, it's going to be hard to maintain that level of safety if you want to increase the density of the use of the airspace. So then, what happens after a century of engineering, where all systems get better and better and better, you inevitably end up with a system where the human is the weakest link, because that's the one thing that only gets better on evolutionary timescales and not on the scale of a century. So Dr. Leveson from MIT said it very good. Human error is a symptom of a system that needs to be redesigned, and inevitably And I think that point is roughly now. You end up with a system where it's the last thing to remove to improve. So that's what we set out to be. And, oh, I can push this button. Let's see what happens. So, let me go back. Can I also go back? Yes. Yeah. So, to get to this safer place, we need to replace the human with systems. That means digitalization, automation, autonomy, and this AI that you hear a lot about. And you have to do that to keep it safe. So the you should not think about these modern technologies as things we do and then we have to also keep it safe. We have to do these things in order to keep it safe when we increase the density of the airspace. So how can we use these techniques to make flying safer? So that's where we had the next one. Oop. So you've seen the 5 levels of autonomy from driving. And I've taken a light stab at translating that into the world of flying, where if you look at it carefully, you know, up to level 3, we've had in flying for decades. As people, when I told my startup idea, many people said, oh, these planes these days, they already fly themselves. Yes, except for this takeoff and landing bit, which, if you think about it, is really the most dangerous bit about flying. So actually, you could define flying as the art of only landing when you really want to, I often joke. So if we want to get, so this, you know, we got covered. That works really well. So it's all pretty safe. And it demonstrates that these systems have made it safer. So it's not like an unthinkable thing. What's called automation today was, you know, science fiction 50 years ago, but we rolled it out and it's doable. So now, how are we going to get to these next 2 phases? And there, we're going to have to move into and discuss what this AI is people keep talking about. So when people say artificial intelligence, it helps to clarify the discussion by asking what that actually means. And then if you drill down, the artificial is easy. Intelligence is actually very hard to pinpoint. So if you look at computer science in the 50s of the previous century, artificial intelligence was being able to play chess. You know, it was the summit of what the machines could achieve. And now that turns out to be a completely solved problem. And Go was actually much harder, but that's also been solved. So in practice, AI means whatever computer science doesn't really know how to do yet. So it's really at the edge of what we need to do. And I don't think, so there it's also natural to throw your hands up in the air and say, oh, you know, nobody knows how these artificial intelligence systems work. And that is because we don't actually know how intelligence systems work. But that's no reason to throw up your hands in the air and think, okay, well, nothing can be done there, therefore, let's give up. In fact, and that's the state of the discussion in much of the industry, is, you know, black box, deterministic, hard to understand. We respectfully disagree. So we've started a project under an innovation partnership contract with EASA, where we try to set out the a framework for a means of compliance for applying a certain category of systems in avionics. So and now I have some time to talk a bit more about what it is we want to do as a company. We wanted to start in VFR, because in VFR you can fly on your own without too much dependencies on the massive system that is ATC and civil aviation. So in VFR, visual flight rules, you're going to need eyes. So to follow the rules, you need eyes. That means we have to make the computer understand what it sees. Now that's artificial intelligence. We try to stay away from that. There are modern techniques in machine learning, which is a sub-branch of AI, where you really apply statistics, a science that has existed for multiple centuries, to what is now this modern big data. So machine learning is to identify, to build systems by doing statistics on steroids on big data. So there, the hard, solid mathematical foundation of statistics can actually bring us a bit further. So we're concretely working on systems, for example, that can recognize runways on a camera. You saw the demonstration just a couple of days ago from Garmin and Cirrus that have the button, pilot is dead, please return. So that works purely on GPS, and because Garmin makes very good GPS systems, that's a logical thing. And if you don't have a pilot, then this button is better than nothing. Before that can be a system where you have the button that says the pilot would like to land the plane himself today because it's a beautiful day and it's the normal operation. You're going to have a replacement for GPS. And currently humans do that by looking out the window. So this is one of the systems we built. Then, so how do you get a system like that certified? How do you prove that it's safe? Because we have to not forget that certification is not, it follows after you prove it's safe. It's not safe because you certify it. That's an important thing to keep in mind. So certification is a means, not an end. So how do we certify, how do we guarantee the design and the quality and the level of performance of a computer system that uses these modern machine learning techniques to recognize a runway or to recognize non-cooperative traffic on a video camera? So for that, what this IPC aims to do is basically create the equivalent of the bird strike test. So you have to realize that currently software is already treated as a special thing in aviation. So normally, when you have an aviation component, how am I on time?
You're late.
Oh. Normally, when you have a component of an airplane, like a part of a wing or a strut or a part of a machine, you put it in the lab, you beat on it, and you say, okay, I can beat this 50,000 times, therefore, mean time between failure is this big. For software, that doesn't work. So for software, instead, first of all, in the fault tree analysis, we pretend it's always going to fail, and we mitigate that. And then we follow a ton of process, and then keep our fingers crossed, and then it's DAL A or B or C. So actually, it turns out that for these machine learning systems that are based on statistics, you can do better. You can do the equivalent of beating on it in the lab 50,000 times. Or, one of my favorite examples, somebody has figured out that if you have a jet engine that is smaller than 1.35 square meters of input, of inlet, then it suffices to throw in a 1.85 kilogram bird to verify that it's one of the tests that go through it. So when you think about it, that's a much stronger test than all these software tests. So it turns out that with this statistical basis of machine learning, we can actually come to those kind of checks and tests. And they take the form of consistency checks on the training and the testing data, sanity checks on independence of parts, and then when you work through the whole process, it turns out that all the ARP and all the DO 178 and 254 things, that all just works, with the small exception of what you would call the low-level requirements for the software, and those where we can replace with, we think, with a number of sanity criteria on how you machine learn. So, we don't talk about general AI, we don't even talk about all machine learning. There's a specific class of, we call them deep convolutional neural networks, with a certain architecture that can fulfill the task of, is there a runway, is it safe to land there, or even emergency landing guidance for helicopters, does this look flat and safe? And there, you can totally meet those design bars. So that's what we set out to do, and then soon, we will be done. Okay, I'll leave the rest for the questions then.
Okay. Thank you, Luuk. So now we know that artificial intelligence is even more complex than ATM.
I don't think so.
Yeah. But I think that artificial intelligence, I think it opens quite fascinating perspectives. But at the same time, it's a bit, if not worrying, at least a bit unsettling. And it poses, I think, a fundamental question of the trust that you can have in artificial intelligence. I remember the words of Topi Manner this morning, and this afternoon, the CEO of Finnair, who said that safety and trust goes together. Mm-hmm. But with artificial intelligence, I think that we have this fundamental question of trust, because it is a black box, and we don't really know what's happening in the black box. Before answering the question that I've not posed, I think that there is, for instance, with traditional software, we have lines of code, we have software development assurance systems. When it fails, we can look at the codes and understand where it failed, why it failed. With artificial intelligence and deep learning in particular, we are closer now to the human brain. We have neural networks and we have learning mechanisms. And after an accident, for instance, you can check the code of the software, but you don't open the brain of the pilot because you only see neurons. And it's a bit the same with artificial intelligence. So how, with a system which produces its own code, its own mechanism, how can we establish trust that artificial intelligence will behave safely? I think that's the key challenge of the coming years. And so that's a question to you, Luuk, but also to the other panelists, because I understand that some of you, at least, are also using artificial intelligence. You can start, Luuk, or whoever.
So first of all, I think it's a valid question to ask because the public has a right to know what sort of weird stuff they are being subjected to. But the idea that you should understand it before you can trust it, in practice, that's always delegated anyway. So very few people who get in the thin air that takes them back home later on understand exactly how the jet engine works, or even barely. And yet, you trust that the people did their work, and so it's trustable. So, not everybody has to understand how it all works. And it's definitely possible to write software where it's very hard to understand what it does. And actually, one of the ways the D178C processes work is make sure you write your software so that you can understand it. So it's not that it's automatically more understandable if it's classical software or a jet engine or anything. So then, it becomes the underlying mathematics of the field where you're going to have to trust experts to some degree that it's valid. But that in itself is also not radically different than how other fields have advanced. I think this explainability is a bit of a red herring. So explainability and understandability, if you try to pin that down, it turns also out that it's impossible to define. So you cannot say this is an understandable system or not on the basis of objective criteria. So in that sense, I think it's really, I compare it to the elevator from 100 years ago, where if you would get in, there would be a person who would operate the buttons. And now artificial intelligence has progressed to the stage that you can push the button yourself and the elevator goes up. And after 100 years, people are not very nervous about it anymore. In fact, if there would be a guy now who would push the button for you, you would ask, what's wrong with this elevator? So,
yes,
I think I want to give other people a chance.
But so maybe other comments, because I think that, for instance, Frédéric, in your application, you are using artificial intelligence. Are you confronted with this issue of how can I be sure that artificial intelligence will deliver what is expected, and how do you do that? What framework do you establish?
So first of all, I think artificial intelligence means or include many different technologies. So there are different categories of technologies that could be applied already today, and that could be developed and further developed for tomorrow's application. So for tomorrow's application, we'll include assisted cockpit, as you mentioned them, or it could be single pilot operations or full autonomous aircraft. So this is more, let's say, in the mid to long term applications, and for that we need to ensure indeed trustability and trustful and algorithms that can be, let's say, improved over time and also scrutinized how they behave. However, short term, I think artificial intelligence is essentially to automate tasks that are too complex for human beings and that may address non-critical applications. And this is where the teams within Airbus and also collaborating with startups and with the ecosystem, with researchers, we try to develop those techniques that automate a lot of routine tasks that are defocusing people from the analysis of what should be analyzed, as opposed to processing data. And this is what we do today, essentially in an industrial way. When we reach accuracy level close to 80-90%, I think we are satisfied. However, for mission-critical applications, this is not satisfactory at all. However, for routing automation, at least it removes a lot of workforce burden from the shop floor to the engineering teams.
So which means that we are not today at a level of reliability that would be enough to ensure critical functions, for instance, safety critical functions.
Fully based on artificial intelligence? Yeah. I don't think so.
Mm-hmm. Yeah. Will you use artificial intelligence in data for safety, Erick?
In D4S, maybe. Already we have attempted to use it for safety intelligence, for the situation mentioned by Frédéric, where we have more and more occurrences. So we have now currently, you have human beings, operators, capturing, putting this information into the ACARE system, for instance, and also risk classifying. And given the volume, it's impossible to cope with that. And it will increase even more. So we have attempted. Honestly, so far, it was not so convincing, but we have recently launched another research study to check with the latest developments if now the system has improved and we can rely more on it.
Mm-hmm. Yeah. And Jean, in the two applications that you, no Pierre, sorry, in the two applications that you showed a moment ago, so you are using also artificial intelligence. So are you confronted with also this issue of how to validate the use of artificial intelligence? What about the also the error rate in your functions, even if they are not safety critical? Yes. I mean, an error is an error. And is there a risk, for instance? I'm thinking of your slide, Luuk, of I mean, to eliminate human factor. But what if we replace human factor by artificial intelligence factor in the end?
You shouldn't do that before you can demonstrate that it's better.
It's true.
Mm-hmm. Yeah. And Pierre?
What we do is we try to, like you said, provide the operators, like pilots or air traffic controllers or airport operators, with some information they can use in the real life. So this is the first step where the validation will be made by the operator himself. If you provide something that doesn't make sense or that sounds weird, you must convince him that it is true, even though if it is not something obvious for him. So the validation, the human is there, and he needs to understand what's going on. Once this is done, of course, the rate of error should be low because the confidence is really important. For example, we provide some information to the pilot about if he changes the speed, this will translate into fuel reduction and time reduction. This must go to, and because of all the data that needs to be processed, the pilot himself cannot do that on his own, but the result that you give to the pilot must be something that he can understand in the end. So, yeah, I think that this is important that those steps are followed because you can not go directly to something that nobody understands. And so we are not doing safety critical. We are only providing recommendation, and I think it's interesting to do it like that because it provides people with something real to see what can artificial intelligence, machine learning can do.
Mm-hmm. Thank you. And Jean, so in the quite complex picture of the ATM that you've shown a moment ago, how do you see the development of artificial intelligence from less critical to very critical functions, and what are the challenges that you are facing?
Well, I think I will go in the same direction than Pierre and Frédéric. I make the difference between what is really fully automated, okay, so where I think we have still some breakthrough to go through, so to get the right technology. But on some domain where you have a lot of data, okay, so there are already applications that will bring a very good added value. Okay, so I will just mention one example of so we have put in place a dashboard for ATM in order to monitor the resilience of the complete ATM system. Mm-hmm. And this will allow you to find in advance an issue that may occur. And today, so we have put a lot of patent on that. Okay, so because we bring a lot of good value positive value on to ensure the resilience, higher resilience of the system. Okay, so this is already, is not tomorrow, this is today.
Okay, thank you. Then I have a couple of questions on the big data project, so mainly for you, Frédéric, and Erick. But you may have also something to say, talking to the other panelists. So on Skywise and data for safety, so I understand that the two projects are not already at the cruise speed, but rather at the proof of concept phase. When do you think that the project will be mature and will deliver results?
Well, I'm not sure we are at the same level, so I will answer for data for safety. No, clearly we are in the proof of concept. We started about 2 years ago to the design, convincing the partners to join us. That was one of the challenge, to convince people to join us to share their data, especially operators. We talk about flight data, for instance, very sensitive. The Commission also is supporting us by funding this phase. So we have spent a couple of years to design and regroup what we needed, so the data, the funding, and everything. So now we have actually a working prototype. We have actually data in the lake, flight data, the occurrence, the weather. We are working on ADSBs. So we are at a stage where we can actually work with the data. In about a year, we will deliver a series of use cases, metrics we agreed upon with our partners. And the operational phase, when we will start the expansion of the program, is for the end of 2020, early 2021.
Okay. So on Skywise, I think we can say that we are fully industrialized now. We started in 2016 with Airbus internal manufacturing applications, where we could demonstrate the value of data analytics by minimum double-digit gains on the or efficiency gains on the applications, internal applications we have implemented. In 2017, we launched it for airlines, and 1 year later, so in 2018, we launched Skywise for suppliers. And this year, we are now more than 90 airlines representing 8,000 aircraft sharing data on or using Skywise as their data platform. And we announced in Le Bourget this year expansion of our ecosystem into a Skywise partner program with IM Integrator to let airlines working with certified IM partners on Skywise. And the way how we have managed this growth and this industrialization was, so of course we had the underlying technologies, but it was also with the demonstrated cybersecurity approach and an approach towards data policy that has been fully trusted by the major airlines around the world, where each airline benefits from a private, segregated environment, and only the data they want to share, and they keep control of those shared data they want to share with Airbus, are shared with Airbus. And doing so, we achieved, I think, a critical mass. However, not all airlines share the same type of data with Airbus, and it's representing, even if it's a huge number of airlines and aircraft, only a fraction of the flights that we observe around the world. We maybe have 35 million flights in our database. However, it's not yet at the full industrial or at the industry-wide level. However, what is interesting also is that as for data for safety, the airlines which operates multi-fleet aircraft, a fleet from Airbus, Boeing, Embraer, so they are really using Skywise in their private, as if it was their private data platform, and we guarantee that no non-Airbus aircraft data are accessible by Airbus engineers to guarantee a strict segregation of those data. And by convincing them, we develop trust with the different parties, and this is where we stand today.
Yes, sharing data is a very sensitive issue for airlines and for any organization, and data governance is really the, I think, the cornerstone of data sharing. How do you envisage data governance within the data for safety program, Erick? And how? Because I think for you, also, an issue is to attract as many participants as possible, because the more data you have, the more meaningful the analysis of data will be.
Yes, so, yeah, first of all, we gather very similar type of data. We talk about flight data, occurrences, weather, ATC data. The difference in the programs, because they are very different in nature, is what you do with the data. So the main use cases you can have when you have such data is to go for predictive maintenance, operational efficiency, or safety. So clearly, if we are named data for safety, because we are going for safety and for safety only. The other platforms usually have also, they sell services, we don't sell safety, and then they go for operational efficiency. In particular, the same for safety line. So we are restricted to safety. So that being said, we still need to convince our partners to share the data. And for that, we need the trust, because they share the data for free. That was mentioned this morning, so we don't pay for that. And they also share the expertise. So that's also a reason why in this phase of proof of concept, we are limited, because we are also testing a governance where we can agree collectively on what we do, what is acceptable to do with the data, because we are constantly balancing the production and the protection of the data. And as far as we are concerned, data for safety, this is a critical path. We are constantly slowed down by the data protection, because we need the trust. And that's a problem that I was discussing with my colleagues, and it's less of a problem for them because they have a contractual relationship. Organizations share their data with them to get a service. So go use them, and they are protected by the contract. For us, it's a very different setting. So the governance is clearly a critical aspect. And what we do, we have a steering board, which is co-chaired between EASA and an operator. And the way we are working is by consensus and with a lot of transparency. After, we have a lot of mechanisms, but that would be too long to explain now.
Thank you very much. It seems that trust is really the key words for those developments, whether we speak of artificial intelligence, data for safety, data sharing. Yes.
I just wanted to maybe complement what Erick just said. In Europe, we are leading the way with respect to data privacy and personal privacy. And GDPR has been a tremendous move forward in order to protect personal privacy, especially in the consumer world. However, when it matters about B2B relationship, sometimes, and we observe that also inside our huge organization, we over-engineer the notion of GDPR and data privacy. And sometimes this could slow a little bit the effort towards collaboration, and especially when it's matter to safety data, where it should be above, let's say, without impacting the data privacy. But we have ways to make data privacy okay, and the culture we have in Europe tends to slow down a little bit the different initiatives towards sharing data. I don't know if you observe the same trends, but I would say on one hand side, we have a regulation that is really a key progress for consumer and our citizenship. However, when it's about efficiency and collaboration towards safety, certainly, but in other domains, we see it potentially as something that could slow, even if we don't share personal data, and with Skywise, we don't share any personal data, nominative data on the platform, and there is no on the platform. However, it's true that by recouping some information, someone could end up into having some information. And this is something that even if we can demonstrate the technology, the culture is really slowing some progress we could collectively do.
Do you experience the same, Erick?
No, we have the exact same situation. That's what I was mentioning by balancing protection and production. So indeed, it's very complex because we are constantly challenged, sometimes to some extreme situations, on how we protect. However, I have to say that it's working pretty well, and we are working in also very much in collaboration with the ASIAS program in the US, and they are quite impressed by what we have been able to achieve in Europe, despite that we have this the data protection. So yes, it's a challenge. I think it can be overcome, but it requires a lot of transparency, trust, discussions, and a set of processes, whether they are technical, or contractual, legal, to reassure the data owners that the usage of the data is okay.
Okay, thank you very much. I think it's time now to have a look at the questions from the audience. So if we could put the Slido questions on the screen, and maybe here I'm going to move because I don't see the questions very well, so I have to leave you. So we have a first question here. How can we ensure free data distribution to all relevant stakeholders? So maybe the question is related to open data, maybe, or do you understand?
So I will be a bit provocative. When it's about being free, I think it's a wrong message, because data sharing, data platform, and all that has a cost. So I think the question is how to have this collaboration with the less cost burden for the different stakeholders. However, the investment is substantial. And if we start by saying, okay, it's free, you can be sure that the people investing may be refrained in sharing the data. However, there is a value of sharing data. It's an industrial value, a safety value, an optimization value. And the cost to share those data should be, let's say, covering the effective operational cost for hosting, deploying those data lakes. And it should be accessible, especially for safety. However, free sharing of data is really, either it's the citizen paying through tax, or it is the different stakeholders, but those are real complex investments.
Okay, so no open bar on data.
If I may, I think actually the question is not really about the data, but the usage of the data. Again, you can have the same data. You may want to sell it for a specific purpose, because there will be a service that you can sell. But if it's for safety, maybe not free, but on a cost recovery basis, so the price tag should be different. It shouldn't be on the data, but the usage of the data you want to have.
Yeah. I've seen a question. It was on the screen. It's not anymore, but I think it was interesting. It was the question of the Hudson River accident. So that's
the third.
It is the third now? Oh, yes. So is the role of the human being dismissed too quickly? Would an AI have landed on the Hudson River? And maybe there's another question. Oh. Would an AI have avoided the flock of birds?
Or, so actually, so first of all, yes, I think that's totally a solvable problem, that you know where to emergency land better than in other places. And actually, so one of our functions is emergency landing for helicopter on visual data, so you can have a plan ready before it happens. You don't have to wait until you lose thrust and have to go through a checklist. And in fact, if you look at the movie, the real heroic part of the pilots was to go against ATC, trying to talk them into going back. So, and it took them about a minute to figure out everything that was wrong, and then they had to go through this manual checklist. So there, I'm very confident we can make a system that can do the perfect thing right away, and also pull off a wonderful landing on the water. That's not to go against the heroic qualities of Mr. Sully, but that is a solvable problem.
Okay, thank you.
Nobody
wants to add anything?
The other question.
Oh, okay.
That one.
There's another question which is related in the end. That's the one on the top. While we have plenty of data on when things go wrong, do we have enough on why things go right in order to hand over autonomy to fully automated systems. Who wants to answer that?
No, we don't.
Anyone except Luuk who wants to answer that? So then, Luuk, you are the option.
So there's this wonderful report by EASA on the use of TCAS in Europe over, I don't know, 2005 to 2015 or so, about a decade. And there's a wonderful pie chart in there, how often pilots do the right thing on the traffic advisory. And the good news is, 3/4 of the time, the pilot does the right thing. So you could say, that's a clear case to hook up the TCAS directly to the autopilot and bypass the pilot, which in Airbus planes, I think, is the default, and the pilot gets to override it. Second time, the pilot does the right thing. So the second alarm, it's slightly better, but still greatly worrying. But before you can make the conclusion, okay, let's take the pilot out of the loop there, you need data on how often the pilot saved the day because the traffic advisory and the resolution advisory were wrong. And there's very little data on that, or actually no. So that pleads for routinely logging absolutely everything. And I think the Europeans should get over their privacy thing because it's safety. I would welcome the regulator stepping in and say, no. This actually, with the special condition for eVTOLs, comprehensive logging has been made part of the rules and regulations, and I welcome that.
Good. Thank you, Luuk. So a question that is not for Luuk. Yes, the one on the top. But I mean, Luuk, if you have an opinion, of course you are free to give your opinion. Why not include also partners for data for safety from business aviation instead of just scheduled airlines? Data provided could be beneficial due to the expanded reach. So that's for you, Erick.
No, it's clearly part of the plan when data for safety will go operational to expand, and then we want to reach out to the whole community, and we don't intend to exclude anybody, including business aviation. But as I mentioned, we are in a proof of concept phase. We need to be focused. We need to learn how to tame the data, how to define this governance. And then when we will go operational, we will have to have a different business model, a different type of funding. We'll have to have a new charter with our partners. And at this time, after 2020, we'll start expanding to other domains. But definitely, we will not exclude any communities from the program.
Because there is a related question on MROs or airlines outside the EU members countries. Will they be able to join the Data for Safety program in the future?
Well, the primary focus of D4S is really for the European system. What we have said is that if there is any data or even organizations that could make sense to have, because it can help us to understand the European system, we would not exclude. Now, the international model is that you have other similar programs like in the US or in Asia Pacific. And what we are doing, we are cooperating with them already today to make sure the programs will be in the future compatible. So we don't intend to exchange data, that would be too sensible, but to exchange information and to be able to make joint studies together. So that's how we intend to have an international reach with such programs.
Mm-hmm. Thank you. And I see a question on data analysis. Could you please share an example of where FDM data and ECARS data has been used in combination to conduct predictive analysis? Are there examples from you, Frédéric?
So I think having data platform enabling the fusion of those data or the correlation of those data can generate a lot of different workflows. Of course, I'm thinking about predictive maintenance applications, for instance, where doing the combination of those information, but it could be on our reported occurrence also to cross-check the reported occurrences with the ACARS data when they are available in order to maybe come back to more factual data points as opposed to the verbal reports that has been translated or reported on a document. So therefore, there are many different use cases, but it's about also being able over time to identify trends. And those trends can just leverage the detailed report over a long period of time that you can balance either by aircraft, by airport, by regions, by and from there try to track the weak signals and identify some routine in the events that may lead to some predictive analysis and then new things to focus on.
Yeah, I may have an example. We used to work with an airline on the hard landing use case, and the hard landing is both monitored by ACARS and in fact automatic detection and by FDM. And using the FDM and large-scale analysis of data, we were able to find some precursors to those hard landings. For example, the aircraft configuration could be one of those, and leading to the landing more prone to hard landings than the full. In fact, flaps 3 configuration was less prone to hard landing than full flaps configuration, for example. So yeah, we can combine those.
And I think we have a kind of a Skywise user forum where airlines exchange their workflows, use cases, and it was interesting to see how some airlines just implement on their environment the data fusion by combining flight events with their flight plans, their flight rosters, their safety reports, weather events, and by doing so they can highlight what are the different trends they have to implement? What are the new flight trends monitoring in order to conduct new investigation, new focus areas? And doing so, they can identify pretty precisely the percentage of particular aircraft that are responsible for this amount of safety event. And they can then launch further in-depth analysis and investigation in order to understand whether it is a question of components, maintenance, or operations.
Thank you. And now I'm taking the last question. That is the third one on the list. No, that's not the one. That's yes, the second on the list. How soon do you think you will be able to have full autonomous aircraft? By other means, I'm a pilot. When should I look for any other job? So it reflects, I mean, of course, the concerns that we have facing technology and all the disruption that will happen in the society. So, do any panelists have an idea of when fully autonomous large transport aircraft will be on the market? And in fact, there are two aspects. One aspect is, when do you think this will be mature from a technological point of view, and then from a societal point of view? Pierre?
Yeah, 20 years ago we said that autonomous car would drive all over the places, and now we are 2020. It was in 2000, and we still don't have autonomous car. So I think that for the aviation industry, it should be quite similar. It's just my point of view.
Luuk?
So there are two different questions. The first, autonomous flights, I think for certain categories of operations, very restricted operational scenarios, is not that far away. For large transport aircraft, I'm not sure if it's a problem worth fixing, because it sort of works. There's actually a pilot shortage currently. That might actually put some things in motion to make it faster. But the thing with predicting the future is really hard, especially the part that hasn't happened yet. But I disagree with the car analysis because flying is actually way much simpler. So the problem with driving is that you have to understand the difference between a rock and a bicycle and a car with a bike rack on the back. And these people there, they do very unpredictable things. So the sky is nice and empty compared to that. And flying means if you see something, don't fly there, with a very minimal set of exceptions. So flying is actually a much simpler problem from a robotics point of view. So we can do that faster.
So autonomous vehicle does exist. So it's not a question of technology. It's more a question of safety. And so we have to think about the way to maybe to change a little bit the way to see the safety, and in order to make progress on this autonomous vehicle.
And for large, if I may, Luuk, to complement, for large commercial aircraft, it's above 100 seats. Before moving to full autonomous aircraft, I think so we are working on single pilot operations, and we see already what changes it requires, not just on the aircraft design, but across the whole industry in order to have this acceptance. So I think it's the industry is heading towards that, certainly, but there are intermediate steps that the industry is working on, and it's pretty complex and a collective challenge.
Thank you very much. Your last word, Luuk.
No, I was just going to say that in general aviation, the situation is, of course, quite a bit different, because that's also far from as safe as the big ones. So.
Right, so I think that with this panel is coming to an end. I think that if there is one main takeaway from those discussions is that on one hand, we are at the start of a digital revolution in aviation. On the other hand, there is a fundamental thing that we need to keep in the aviation system, that is trust. And trust is something that is built slowly, with time, regularly. And I think that we have a mature industry, and we have also regulators who are there to ensure that with the evolution of technology, the trust will be kept in order to ensure that safety will be maintained. So I would like to thank very much the panelists for their participation, and also the audience for the interesting questions. And yes, this panel is coming to a close. Thank you very much.
So thank you also from us, Jean-Marc, for a very interesting and stimulating panel with a lot of energy in it, I think. The drinks monitoring went differently according to different people, but, you know, it was kind of in there. It was our final panel for today, and you're now all invited to a get-together, which is being hosted by Traficom, which will be, again, in the Winter Garden, and you'll find snacks and drinks over there.
Yeah, and the event will go on until 7 p.m. We will continue tomorrow morning at 9 a.m. sharp. Please enjoy the refreshments at the Winter Garden, and thank you all for the day. See you tomorrow.
Thank you.